Hey everybody, welcome back. Just want to work through an example here that shows different ways to work a problem like this. It's known, of course, that if 1 plus root 2 is a factor of that polynomial, then its conjugate 1 minus radical 2 is also going to be a factor by the quadratic formula. We're going to start with synthetic division. This is going to take a bit, but it's okay. 1 plus root 2, we're going to divide knowing that the 3, negative 2, negative 11, and negative 4 should work out properly. Now you should know how to use synthetic division before watching this video, but we know we're supposed to get a 0 there, so I like to put a happy face in there. And let's just crank this out. Bring down the 3, multiply, so it's going to be 3 plus 3 root 2. Add straight down, we get 1 plus 3 root 2. And now we've got a nasty multiplication to make. So I'll do that as scratch work on the side. That's 1 plus root 2 times 1 plus 3 root 2, which gives us 1. This is going to be radical 2. That's going to be 3 radical 2 or 4 root 2 in the middle. And then our last term is plus 6. So I get 7 plus 4 root 2. I'll go ahead and put that back in here. So that's going to be a 7 plus 4 root 2. And if I add straight down, I get negative 4 plus 4 root 2. Now, when I multiply this out, I should get positive 4 so that I get my 0 at the end. But let's just verify that. That's going to be 1 plus radical 2 times, and instead of multiplying it by 4 plus negative 4 plus 4 radical 2, I'm going to bring my 4 outside. It's negative 1 plus root 2, and I see that these two are conjugates of each other. That just gives me negative 1 plus 2, or 1, and so my answer is indeed 4. So I'll write that 4 right here, and now I did get that to turn out to be 0. The cool part about this is that now we've got an answer that we can work with our 1 minus root 2. So here we're going to do the second half of this. Bring down the 3, multiply. I'm going to get 3 minus 3 root 2. Notice the root 2's cancel out here in the addition. This gives me 4. This is now 4 minus 4 root 2. And of course, this is supposed to come out to be 0, and it does. And now we can see our final factor, 3x plus 4. So we have, it says find the other factors. So the two other factors were 1 minus root 2. And of course, that should not be written that way. That should be written as a factor. So let me just finish this out. The two other factors are going to be 3x plus 4, which came from our final quotient, and then x minus that second factor, which was 1 minus root 2. Okay, that's how we write that in factored form. And the first one, the original one, was was x minus 1 plus root 2. So these were all of the factors now. So here are the two we were looking for, because the one that was given was this guy right over here. I'm going to just box that. You could actually distribute if you wanted to, but there's no need to do that. And method number 2. Second method, we're going to do this by creating the quadratic from the root, and then we're going to divide using long division. So since we know that 1, and we just saw the factored form of this, 1 plus radical 2 in factored form. We just saw that, and we also saw the other one, x minus 1 minus root 2. Now, we don't know what the third factor is, so we're just going to leave this alone. But in this case, I'm going to multiply all this out. And as you recall from class, we like to do this. Distribute that negative, and then distribute this negative, and then go ahead and multiply using this first term as the entire first term of what's going to be a difference of squares. So x minus 1 squared minus 2. And so we get x squared minus 2x plus 1 minus 2, or x squared minus 2x minus 1. Now what is that? That's the quadratic that we can now divide using long division. So I'm going to write that out right here, x squared minus 2x minus 1. And we're going to divide this into the 3x cubed minus 2x squared minus 11x minus 4. This is not an easy long division, but we can get it done. X squared goes into 3x squared 3x times, and when we multiply back over here, we get 3x squared minus 6x squared. Excuse me, that's a cube right there, 3x cubed. And then minus 3x. Adding straight down. In this case, we subtract these. We're going to switch the signs and add. So that's going to give us 4x squared. And this is going to give us minus 8x. Bring down the 4. And as you can see, the second part of this just gives us a plus 4. and just verifying that this is going to be 4x squared minus 8x minus 4, and it does. So that means it works out just fine. So this one here is our third and final factor. And let's go to method number 3. Method number 3 is a little bit different. Once we've reconstructed, we can reconstruct this from the roots. So we know that the original polynomial was 3x cubed minus 2x squared minus 11x minus 4. And as you can see, we know that that's going to be a product of two things. It's going to be a binomial and a trinomial. And this trinomial we actually found by multiplication, x squared minus 2x minus 1, if you look back at the last session, so the last problem. So if this is the case, then we know that when we're multiplying this, we could say, well, that's an ax plus b. And there are a couple things that we notice right here. That the ax multiplied by the x squared has to give us this, 3x cubed. So therefore, x cubed has to be 3x cubed, and therefore a has to be equal to 3. That's the first thing. The second thing you notice is that this b term has to be multiplied by that 1 right over there in order to give us this term right over here. So that means that b times negative 1 has to equal a negative 4, or b has to equal 4. So we can quickly see that 3x plus 4 is the final value. Of course, that's having known already that the conjugate was the other one, and then multiplying those out. So you can see those three different methods for finding the other factors. Any of those methods works really well. Okay, hope this helps.